The CDC estimates that foodborne diseases cause approximately 76 million illnesses, 325,000 hospitalizations, and 5,000 deaths in the U.S. each year. Without careful processing, many kinds of food can become hazardous. Unseen pathogens can render almost anything toxic. Food processors and health officials need to validate food and facility cleanliness by quickly and accurately taking samples from various surfaces to test for pathogens. The conventional sampling method, however, has remained much as it was during World War I.
The world cannot afford to continue on the current path of essentially ignoring the importance of an accurate and effective sample. To improve the food supply safety, new sampling technology must be implemented. In order to locate and ultimately reduce the illness-causing pathogens, that's where the MVAC comes in.
As no surface is completely smooth, swabs and sponges are not capable of reaching pathogens that lurk in microscopic cracks and crevices.
Although Dr. Bradley's product vision began with food safety, the need to know what's in the cracks and crevices on a surface is critical in many industries. Defense, bioterror, biologics, forensics are all industries that require superior surface sampling. That's why we are so excited about our technology. The MVAC is designed for that purpose.
The system uses wet vacuum technology to cover an area with a sterile solution and then vacuum it up along with any microorganisms that may be present. Traditional swabbing can only effectively cover a few square inches, while one MVAC sample covers up to 288 square inches, increasing the odds of discovering bacteria. Traditional sampling methods must undergo yet another step called elution, the extraction of sample from the device. The elution step is not required with an MVAC sample.
Cantaloupes, which have been implicated in outbreaks of salmonellosis, have intricately webbed surfaces which can enable bacteria to escape detection by traditional methods. The fact of the matter is that many products reach the consumer and are contaminated despite the fact that they have been sampled for pathogens. We simply need better methods for detection and better methods for sampling. The MVAC can improve our ability to physically locate and extract pathogens from the surface of complex foods like cantaloupes. I believe that it's a promising technology.
The MVAC can be used on virtually any surface, including stainless steel, masonite, tile, carpet, fabric, vegetables, and meat. In addition to food safety, hospital rooms or industrial clean rooms can be monitored with confidence, while police and homeland security applications include detection of harmful pathogens and biohazards. The sample bottle can be sealed to preserve the integrity of its contents as evidence.
Many of the foodborne disease outbreaks that we've seen this year alone, we know we can trace their origins back to contamination in the processing plants where these foods were produced. Historically, in order for us to go into a plant and identify sources of these organisms, we've relied on sponges and swabs, which are very inefficient in giving us a representative sample that we have confidence in. The microbial vac system is really breakthrough technology that allows us to physically remove those organisms from cracks and crevices, allowing us to pinpoint sources of contamination, clean them up, and ultimately produce safe foods.
Consumers want to trust that the food they eat won't make them ill. The implementation of the MVAC into sampling programs can help to ensure the pathogens are located and detected prior to products entering into the food supply. Using the MVAC will improve the safety of the food we eat and also boost consumer confidence and trust.
To learn more about this story, visit Microbial Vac Systems at m-vac.com.